Now, let us understand about the trigonometry identities. An equation is called an identity when it is true for all values of the variables involved. An example is shown on the screen. Similarly, an identity equation having trigonometric ratios of an angle is called a trigonometric identity. An example of a trigonometric identity is shown on screen. Now, let us derive the above identity. Proof. Consider a triangle ABC with right angle at B. Here, the side AB is adjacent, BC is opposite side, and AC is the hypotenuse. From Pythagoras theorem, we have equation 1. Now, divide both sides of equation 1 with AC square as shown on screen. We know that AB, AC are the sides of triangle representing their corresponding sides. We use them to define the ratio of adjacent to hypotenuse as cos function and ratio of opposite to hypotenuse as sine function and substitute them in above equation 1. Finally, we obtain the first trigonometric identity as shown on screen. Now, let us derive another such identity. Proof. Let us consider a triangle ABC with right angle B. From Pythagoras theorem, we have equation 1. Now, divide with AB square on both sides of equation 1. We get as shown on screen. We know that AB, AC are the sides of triangle representing their corresponding sides. We use them to define the ratio of opposite to adjacent as tan function and ratio of hypotenuse to adjacent as sec function and substitute them in above equation 1. Finally, we obtain trigonometric identity as shown on screen. Now, let us prove one more identity. Proof. Let us consider a triangle ABC with right angle B. From Pythagoras theorem, we have equation 1. Now, divide with BC square on both sides of equation 1. We get as shown on screen. As we know, AB, AC and BC are the sides of triangle representing their corresponding sides. We use them to define the ratio of adjacent to opposite as cot function and ratio of hypotenuse to opposite as cosec function and substitute them in above equation 1. Finally, we obtain trigonometric identity as shown on screen. Now, let us list out all the identities together. The above identities and some more identities obtained by performing simple algebraic operations like addition, subtraction on the previous identities are listed below for quick review. Attempt the following questions. You can click Solution tab to verify your answers. Now, let us solve some example problems. Example states that cot theta plus tan theta is equal to secant theta cosec theta. Given LHS is as shown. Since cot theta is equal to cos theta by sin theta and tan theta equal to sin theta by cos theta, by taking LCM, we get as shown. Since cos square theta plus sin square theta equal to 1, we get 1 by sin theta cos theta. Since 1 by sin theta equal to cosec theta and 1 by cos theta equal to secant theta, which give as shown. Given example is to show tan square theta plus tan power 4 theta equal to secant power 4 theta minus secant square theta. By solving step by step, we get as follows. Finally, we obtain LHS is equal to RHS. Example is to prove that root over 1 plus cos theta by 1 minus cos theta equal to cosecant theta plus cot theta. Consider LHS as shown. Now, divide it with 1 plus cos theta both in numerator and denominator. Then by cross multiplying, we get as shown. Since 1 minus cos square theta is equal to sin square theta, we obtain as. Now cancel square and root. We obtain 1 plus cos theta by sin theta. By splitting the equation, we get 1 by sin theta and cos theta by sin theta. Since 1 by sin theta equal to cosecant theta and cos theta by sin theta equal to cot theta, we get RHS as cosecant theta plus cot theta. Here we are going to solve some examples on trigonometric identities. Example, prove that root over secant square theta plus cosecant square theta is equal to tan theta plus cot theta. The solution is as follows. Here secant square theta can be written 1 plus tan square theta and cosecant square theta can be written as 1 plus cot square theta. By simplifying it, further we obtain the equation as root tan square theta plus cot square theta plus 2 tan theta cot theta, since tan theta plus cot theta equal to 1. So, we write the above expression as shown on screen. Here root and square will get cancelled. Thus it is equal to tan theta plus cot theta. Thus LHS is equal to RHS. Knowledge check. Attempt the following questions to check your understanding. Let us look into a few exercise problems. You can click Solutions tab to verify your answers. Try to solve the problems in the practice zone on your own.